Databases that power today's complex applications are harder to troubleshoot than ever. Whether you're a DBA, SRE, or application developer, you need to understand how the databases that your services depend on are running and be able to troubleshoot issues when they arise. With the database list page, get a bird's eye view of the health and performance of your entire fleet of databases in order to intuitively triage your databases in near real time. Setting monitors against key health metrics allows you to get paged on them directly, and you can easily filter the tables by different attributes, including the 3 database types that we currently support: Postgres, MySQL, and SQL Server, which can be hosted on premises, in the cloud, and with cloud-managed services like RDS. To help understand database load, Datadog displays active connections for each database. Active connections represent the number of sessions currently running queries that are either working or waiting for a resource at that specific point in time. When a database has a high average of active connections, it may be at risk of being overloaded, and queries may be blocked from being executed. Let's check out this host that has a high number of active connections to get an idea of what's going on in one of our most in-need databases. Clicking on that particular database shows us more details about that host, helping you identify any events affecting performance. Looking at my top queries, I can see the queries that are currently running on my database and pinpoint which ones are being impacted by specific wait events. These are the resources that queries are waiting on to run, helping you understand where queries are spending most of their time. We can also switch our view to see how queries are impacting each other through blocking queries. We can alternate between the perspective of what queries are blocking as well as the queries that are waiting to better understand and mitigate the impact of root blockers. We can also identify the direct calling services that are putting load on our fleet, allowing us to attribute slowdowns to our calling services and visualize which services rely on each database. Here we were able to investigate an inefficient database and dig into it down to the query level. In addition to troubleshooting, you also care about proactively optimizing query performance. So let's dive into how DBM can help with that. Query metrics allow you to view performance of queries across your entire fleet. Here, we have a list of normalized queries, which are a set of queries that have the same structure, but with different parameters grouped together. You can filter them to isolate the queries running in a particular environment, such as prod, or a specific database that you want to optimize. Looking at the total DB time metric or average latency to see which queries have the greatest load on your database is a great place to look for queries to optimize, since even small optimizations on these queries can lead to a significant performance improvement. Let's hone in on one in particular, for example, one that's taking a long time to execute. We can see the normalized query, as well as tags about all the hosts the query is running on. We can also look at the query's explain plans, which are the different steps the database takes when it goes to run the query. They can be used to identify parts of the query that may be running inefficiently and can be optimized, or where the schema is not optimized to run the query, such as when it's missing an index. For instance, in this query, you can see that multiple sequential scans happen per query execution. A sequential scan is a very costly operation as it reads all the rows in all the pages of a table each time it's invoked. Sequential scans are often caused by inefficient query writing or missing indices. In this case, the query is okay, but we probably want to add an index on the customers field. This would give you significant time and cost saving, since it would take less compute power per query. While the Query Metrics tab shows you a collection of your normalized queries, the Query Samples tab shows you the individual executions of a query. Query Samples allows you to present the data from these query executions in a variety of ways, providing you with key insights you need to begin optimizing your queries. For example, we can use query samples to compare the relative computational cost of different explain plans over time. If there's an explain plan that looks to be more costly than the others, or there are changes in your explain plans, we can quickly detect it from the chart that we're currently looking at. Once you've found an explain plan that's worth investigating, You can then look at each query instance and explore the IP and host of the most costly ones. To summarize, whether you're a DBA, SRE, or application developer, database monitoring allows you to troubleshoot slow databases as well as proactively optimize queries, all in the same place that you're already monitoring the rest of your tech stack. To get started today, enable a free trial by visiting our website.